Hi guys, so we're here today for another tutorial, which is topic is shear reinforcement design and SCP code 2001 and 2010-2015. So I'm going to explain how we are going to use this program and how I categorize the important datas and sections that we're going to use. So here is the input. So all users here we're going to put data. So from the word input, so we're going to encode data here. So here we're going to wait after inputting the data, so the program will automatically produce the output, which is here. So which are the expected value we're going to get. So this part is the 2001 output of 2001 and the table of 2001, and the other part is the output of 2010-2015 and the table of 2010-2015. So while going to start, I'm also going to explain some part of which are we need to explain. So here also the user will input. So kitain nyo, so just like here also we're going to put input, so as a guide. So going to start. Okay, so I'm going to use the example from our Let's Analyze. So here we have a given problem and also have given datas. So the FC prime is 28 megapascal, Fy is 276 megapascal. So leg, we have a two leg here, so DL, which is the dead load, we're given about 36. Live load is about 54. Length is about, it's referring to the length of the beam, which is 7.2. D is the effective depth of our beam. So T we have 2.5, and the beam base or the beam width, so we have 350, and the stirrup, diameter of stirrup, we're going to assume about 10 millimeter. So why 10? Since here the given reinforcement are about 20 millimeter and 28 millimeter, which is the 20 is in the upper part and the lower is the 28 millimeter in the downward part, which is the number that exceed about 30 to 32 millimeter. So that's why we're going to use the 10 millimeter diameter of stirrup. So after putting the inputs of the data, as you can see, the outputs is already encoded by the program, and the specific value needed for uniform load, Vmax, Vu, Vc, Vs, and also we can check here that our design is already okay. So if the section is already okay, we can proceed down here and also to our table. So after inputting also is you can see that the values from 2001 is already encoded, the table also, and in output of 2010 and 2015 as well as. So here after we input, we're going to go back here, which is the S, which is the stirrup spacing, which is we have in 2001 we have 72.9, and in 2010 2015 we have 70.12. So we're going to assume here about 70 mm. Okay, 70 mm. So after assuming, we're going to identify which region is located. So since it is 72, which is lower to 86, which is this here, which is the less 1/2 BC. So since we have only chooses 2, so the one that will govern is the 70, but our S max is 281.25. So let's say it's about 275. So here after we input, so what happened here is also the same what will happen here on 2010 2015. So what we do here is in 2001 we input also 70. Here since it is 70.12, so it's okay to assume lesser here. So we can assume let's say 50. Okay, 50. So after putting also have also get the data we need. So here in 2010 2015 the S is located between okay, we have 70. Also it is located less than 1/2 VC, which is less than 288, right? Less than 88.55. So we're going to use the D/2, which is the 281.25 as our S max. So we're going to back here in the table of 2001. So we have already the data needed for the X, VU, VS, and S. So after getting the S programmed by the Excel, the user will input depending in their desired design for their own desired spacing design in the stirrup, which is we can say that here in at X of 0.5625 we're going to put about 70. Okay, 70. At 93.31, let's say we're going to put 75. Okay, and here at 137.24 we're going to use 125. And also, so 2 meter of the beam is we're going to use about, so it's safe to assume less than the numbers given by the program. So it's better to be safe if we give lesser than the value given by the program. So it's better to put 250. Okay, this divisible by 95. and you can say 2, 2, 3, 2, 5. So here are the number of stirrup, which is the n, number of stirrup at 0.5625, which we have 870, we have 870 millimeter, and 6, we have also 6. So we're going to add 70, same as here 7, which is have 7 at 275, 4 at 125, and 2 at 250. And at rest is already constant. So we're going to proceed here for the next, which is the 2010-2015 table. So we already input and it is already okay, no? So since it's okay, we are ready to proceed, which is we put we say about 50, we assume 50 to be safe. 50, so we have the first stirrup about 12.5 mm. So here we're going to assume about better to assume it is 50. Okay, also here we are safe to assume 75, so I prefer to use as this divisible by 25. So next is 131.26, so 125. Okay, sure. So 245, you put 225, and last one is 1875. Okay, 1875, the same. So here are the values, the number of stirrup we're going to put in our steel in the beams. So our shear reinforcement, so 11 at 50, also 9 at 50, so we have total of 20 at 50. So 7 at 75, 4 at 125, and 2 at 225, and the rest are constant. So thank you for listening and watching my tutorial. I hope you have learned a lot, and that's all. Goodbye and thank you.